So when we left off, we had learned how to calculate average atomic masses using the weighted method. So in this type of example, the abundances, like the percentages right here, these were given to you already. And the average mass for that particular isotope was given to you already. So when information is given to you this way, it's pretty straightforward. You multiply the decimal abundance by the average value, and you get subtotals, and you add up the subtotals. But what if you have raw data, and what if you don't know the numbers as far as percentages? So we're going to take a step back. We're going to do an example of a problem where you have to figure out these numbers yourself. Okay, so I'm just going to, there's some space on the back of your notes because you're going to need like a whole page. So just flip over completely to the back of your note packet where you have some space and start at the top. And I'm going to do an example there.
You did some
Just draw a line, cut it in half. We'll do another one underneath. Okay, so let's say that I own a car dealership, all right? And I have 3 varieties of cars on my lot. The first variety is your typical kind of like Camry / Accord sedan, right? A typical regular car. And let's say that I have 20 of these on my lot, okay? And let's say that when I bought these from the factory, let's say that I paid the factory $700,000 for those 20 cars, for them to ship me those 20 cars. All right, my second variety of car is an SUV, like a small size SUV, kind of like a RAV4, right? And let's say that I have, these are more popular these days, so let's say we have 30 of these. And let's say that I paid factory $1,200,000 for those 30 SUVs. All right, and now let's say that the third type of car I have, these are becoming really popular. It's like a spider car, which is like 2 front wheels, and the back is just like 1 wheel. Like Terry Cohen drives one of these. I remember came here over the summer one time, and they were practicing in the BG Memorial Stadium, or the football field, and he was driving it around a lot doing figure eights with who's the other guy he was with? Darnell Mooney and with A-Rob. And so they were tearing around. And Chestline was mad because they were, the parking lot was just freshly coated. Anyways, so let's say that we have 15 of these. And let's say that they cost, or let's say that I paid $330,000 for those. Okay, so I need to figure out what the average cost of the car is on my lot. And here's what I have to figure out. I need to figure out the abundance, the fractional abundance of each of the varieties that I have. And I also need to figure out the average cost per each of these varieties. So what I'm going to do is, the first thing, that's the easiest thing to do, is to figure out the total, right? How many total cars do I have on my lot? Well, 20, 30, 50, I got 65. So because we know that there's 65, the abundance is pretty easy to figure out. It's just the number of that variety divided by the total. So the abundance for this sedan is 20 over 65. Okay, so I'm going to make another column here. Abundance, and so that would be 20 over 65. We could calculate this as a decimal, but that's not really that important right now. For the SUV, it's 30 over 65.
Dude,
How's it going?
it's going, man. How are you?
I'm doing great. I'm doing my weird car example that you don't like.
Weird car example.
That's right.
I don't like this one?
Well, you made fun of it.
I don't feel like I've ever had an opinion on it.
All right, just go away. Just go. So, the abundance is pretty straightforward to figure out, right? You got to figure out your sum of your abundances should equal 1. Okay? All right. So now I need to find out what the average cost of each of these varieties is. So, average cost per car. And so I'm just going to take the dollars that I paid of that variety and divide it by the number of cars I have of that variety. Right? So this is going to be 700,000 divided by 20. And here I will calculate it out. Okay, so 35,000 per car for the sedan. And then, oh, I should have kept with the same colors. That's all right, I'll do it this time. So $1.2 million for 30 cars for the SUV. And then for the Spider, okay. Does everybody see what I did so far? Figured out the average cost per car of within the variety. So the question is, what is the average cost per car using the weighted method? Remember, the weighted method is always multiplying the decimal abundance by the average per category, which means I'm multiplying these two columns together and coming up with 3 subtotals. So 20 over 65 times 35,000. 30 over 65 times 40,000. 15 over 65 times 22,000. So I will get 3 subtotals. Yikes. Come back. All right, so that's going to be 10769. Now, here's a little note about counted items. You see how these numbers here, these are whole objects, right? You don't buy half a car. And so whole objects are immune from sig fig consideration. It's like saying that this has infinite sig figs. And so does this, and so does this, and so does this. So when I take a number like 20 divided by 65, this is misleading because it looks like it only has 2 sig figs, right? Or it looks like it has 1 sig fig, right? No, it is infinite. So sig figs, the numbers here are not limiting in terms of sig figs. What is limiting is the cost. Okay? All right, so, and going back to this calculation, we're going to have to round this to 11,000. All right, now just for the sake of making a better number, I'm going to modify this because this is going to tank our results. So I'm going to go back here and change this orange number, the 40,000. We're going to say we're going to give it 2 sig figs. So we're going to call it 4.0 times 10 to the 4th. Just so that it doesn't... No, actually, I would have had 2 sig figs anyways because there's 2 there. So, hey, look at me. All right. 30 divided by 65 times 40,000. 18461. Let's call it 18,000. And then the last one. Okay, so in the end, our average, we're going to be adding these together. And the rule for addition is fewest decimal places, so that's not a problem because none of these have decimal places. So the average cost of the car on my lot is $34,000. Now, what's important here is you understand the process. It doesn't really matter what the cost is, right? In any sample where you are given raw data, you must first establish what your abundances are. You got to find the total count. Here I added up 65 cars. Yeah. Here.
For the last one where it says 5,000, would it be 5,100?
Yeah, whoops, you're right. You're totally right. I missed that. I was thinking it, but I didn't write it. So that would be 34,100. Okay. So establish your abundances. And then realize how many categories you have. We had 3 categories here, right? Each category has to have an average. There was an average cost for the sedans. There was an average cost for the SUVs. There was an average cost for the spider cars. And then once you have those values, those are the values that you multiply, and then you come up with an answer. Now, let's do another example closer to what we're going to be doing in the lab, and that's the one actually in the notes. So right down here, where it says preview of Beanium Lab. All right, so we've got 3 varieties of beans. Okay, and they give you the number of each, and they give you the mass. Now, this mass that they're giving you is the mass, the total mass for that sample. Okay, so let's add some new columns here. So abundance. So I need to figure out the total number here so I can do an abundance. So 198 plus 131 plus 92. We're dealing with a total of 421. So our abundance for bean type 1 would be 198 over 421. And so that would be 0.470309. I'm writing it with 6 sig figs because I know at the end of the day that's more than I need. And my numbers, my abundance will not be limiting as far as sig figs. Okay, because remember, if it's a counted object, they have infinite sig figs. All right, 131 over 421, 0.31164. And then for the last one, 0.218527. Okay. I have my abundance. Now I need the average per category. So what is if I said find the average mass per bean for bean type 1, how would you find it? Yeah, Caden.
You would take the mass and divide it.
You're right, keep going.
Yeah, you would take the mass and divide it by the number.
Right. So average per bean, right? It would be, what we're really getting is we're getting mass per bean, so grams per bean is what the unit would be. So I'm going to take 34.86 grams and divide it by 198 beans. and that's going to be 0.176. Now, here is where I am limited to sig figs, because the mass is recorded to have only 4 sig figs, so 34.86 divided by infinite sig figs gives me a number with 4 sig figs, and that's going to cause us to end here. 0.1761 for the first variety. Okay? For the second variety, I'm going to have to draw on some lines here because I'm already stretching this out a little bit. Okay, for the second one, our mass is 29.74 grams over 131 beans. So the average for that category is 0.2270 grams per bean. And then for the last category, our mass is 16.75 grams per 92 beans. It's going to be 0.1821 grams per bean. All right. So we calculated the average mass per each type of bean. We calculated the percentage, which was the abundance, right? Although I didn't do a percentage, I just left it in decimal form. I left it in decimal form because I knew decimal form is what I use. So now let's calculate what the average is going to be. So let's go back to color coding. For the first isotope, I'm going to take the abundance of 0.470309 and multiply it by the average of 0.1761. I can keep 4 sig figs from this, so 0.08282. For the second type, my abundance was 0.311164 times the average of 0.2270. .07063, and then for the last, our abundance was 0.218527, and the average was 0.1821. .03979. Okay, I have my 3 subtotals. Your last step is to sum them up. As far as when you're adding, all of these numbers have the same number of decimal places, right? They all have 5 decimal places, so the average is 0.19324 grams per bean. And this is the average according to the weighted method. This is a lot more work than a regular isotope problem because this was raw data. Right? So when you see a problem like this, it can come with your data partially processed or unprocessed. Like your homework last night on the calculation of average atomic mass, you were given the isotope averages and the abundances. All you had to do was multiply them across, get subtotals, and add them, right? This is how you approach data that is unprocessed. It's just raw. You've got to figure this out and this out before you do the calculation. And that's what the lab is about today. Okay? All right, so let's do one more example, slightly different. I'm going to go back to where there's room here. Okay, this one actually will be less work, but I want to still see if you can figure it out. First, I need some raw data. So, how many people in here are 15? Actually, let's start that, let's go the other way. How many people here are 16? Okay, so 1, 2, 3, 4. Okay, so there's four people in this room who are 16 years old. There's one person in this room who is 44 years old. And then there's the rest of you who are 15, so let's count up how many there are. There's, let's see. Okay, so there's 13 people who are 15 years old. I want to know the average age of the person in this room. And this is our raw data. What did I say the first thing you must do is? Yes, establish your abundances. So, how many total people are in this room? Wait a minute, that's not right. That's a 23, not 13. My bad. 20, 23, 4. Okay. So we're talking about 28 people. And there are three categories. So the age, you don't need an average for the age in this case. We're just going to leave it at 16, 44, and 15. But what do we do now? Why did we have to add up the total? What are we going to do with that? Abundance, right. So for the... the abundances will be, for the first category, will be 4 out of 16. And 1 out of 6. Darn it, I keep doing that. Not 16. 4 out of 28. 1 out of 28. And then 23 out of 28. Okay, so those are abundances. And so you're just going to multiply these by the ages and get your subtotals. Yeah, kidding.
Why would we not, find the average? Like, why would we not divide the numbers into two?
So in this case, the reason why we're not doing the average is because when you ask for your age, it's not like I said, you guys didn't tell me 16 and a half, 16 and a quarter, 16 and 9/12. Like, we didn't get that far into it. Like, we could technically do that, but just for the sake of just doing the problem a little more quickly, we didn't bother with the averages for that one. But in your lab today, your lab is going to be more like this, okay? So the average age in this classroom is 16. Even though the vast majority of you are 15, looks like I brought up the average a whole year by being here. Sorry. Okay. Questions on how to calculate average atomic mass from raw data? Okay. So we're going to transition and talk about the lab before we do it. So let me stop recording this.